Okay, so now we're moving on to volumes of revolution around the y-axis. So the difference is now we have some sort of curve, maybe like this, that we're rotating around the y-axis to form some sort of 3D shape like this. And we're going to consider curves of the form x equals f of y. The reason for this is it's going to be much more convenient if we use this, and also the kind of questions you're going to be asked both in the book and in the exam are questions where you can rearrange it. If it's not already given in the form x equals f of y, you can rearrange it to get the equation of the curve in that form. So we're going to do exactly the same thing as we did for rotating around the x-axis, but this time, so we have our curve x equals f of y between two values y equals a and y equals b, and we have this region which we're rotating 360 degrees or 2 pi radians around the axis. And we get this shape, and we can do the same thing as before. We can consider, not very good at drawing it, but we can consider these sort of discs. So we've got one here, and if I redraw of width here delta y, and we can approximate each of these by a cylinder of height delta y and radius x. So this value here is the x value. And then we want to take the limit as delta y goes to 0 of the sum from y equals a to b of the volumes of each of these cylinders. Each cylinder has a volume pi x squared delta y. And again, as we take the limit of a sum, we get the integral. But this time we get the integral of pi x squared dy. So that's something slightly unfamiliar because we probably haven't very often integrated with respect to y before. And these limits are limits for y. So that's something people sometimes mess up. They use x limits, but you must use y limits because we're integrating with respect to y. Okay, so let's see an example. If we consider the curve y equals root x minus 1, where y is between 1 and 3, and the question is the region. So if we just sketch it, root x minus 1 looks something like this, and then y is between 1 and 3, and we have this region here which we're rotating to form some sort of solid that looks kind of like this. So we need, so sorry, I'll just finish the question. The shaded region is rotated 2 pi radians about the y-axis. Find the volume of the resulting solid. Okay, so we're going to do the integral from 1 to 3 of pi x squared dy. But what is x? Well, we need to rearrange to find x. So if we've got y is root x minus 1, y squared is x minus 1, so x is y squared plus 1. So this integral is the integral from 1 to 3 of pi times y squared plus 1 squared dy, which is the integral of pi y to the 4 plus 2y squared plus 1 dy. And then we can just use year 1 integration. So we get y to the 5 over 5 plus 2/3 y cubed plus y between 3 and 1. And then if we put in the top limit, we're going to get 1004.44 over 15 pi. And if we put in the bottom limit, we get 28/15 pi. So the answer is 1016 over 15 pi. And that's it. So it's quite nice to leave answers in terms of pi if they're, well, I mean, you have to do that if you're asked to give an exact answer, but if not, of course, it doesn't matter. Okay, and then we'll just do one more example. So if we consider the following region, I'll do my best to draw this. So we have a curve. Well, first of all, we have some straight lines. Actually, I'll do it in a different color. So we've got 3 straight lines here. And then we've got this curve that looks something like this. Okay, it's supposed to be symmetric because obviously we're going to rotate it. So this is a mushroom. And we're told that the top curve, the curve on the top, is a quarter x squared minus 8 root y plus 4y equals 0. And the bottom 3 are just straight lines. So this is -1, this is 1, this is -4. The top here is 4. And what we want to do, the question is find the volume of the mushroom formed by rotating this region uh, 2 pi radians around the y-axis. Okay, so this is a little bit more demanding. So we need to rotate, so we can kind of split this up. If you think about just the piece below the x-axis, as we rotate this region, we're going to form a cylinder. And the height of that cylinder is 4, and the radius is 1. And so the volume of the cylinder is going to be pi times the radius squared times the height, which is 4 pi. So there's no need to really do anything there in terms of integrating. I mean, you can if you want, but it's just not necessary. For the top, we have to be quite careful. So now we want to do some integration. We're going to need x equals f of y, which we have, or we can at least rearrange to get something like that. So we've got a quarter x squared equals 8 root y minus 4y. So x squared, and I'll just leave it as x squared, is 32 root y minus 16y. So the volume of the top part is going to be the integral from 0 to 4 of pi x squared, well, x squared is this, dy. And then again, we can just apply year 1 integration directly. So 32 root y, that goes to 32y to the 3 over 2 times 2/3, which is 64 y to the 3 over 2 over 3. And then we want to take away integral of 16y is 8y squared. And that's between 0 and 4. So clearly if we put 0 in, we're going to get 0. And if we put 4 in, we're going to get 4 to the 3 over 2 minus 8 times 4 squared. And then 4 to the 3 over 2, well, that's 8, isn't it? It's 2 cubed. So we've got 64 times 8, which I think is that 256. Oh no, 512, isn't it? Over 3 minus 8 times 16 is 128. And then 128 is something over 3. Let's see, that's 384, I think. So we're looking at 128 pi by 3. So hopefully that's the right answer. And yeah, so we can see that's the method. Now, the other thing I want to say, just to finish, is what happens if the angle we rotate by is not 2 pi radians. So let's just say, very quickly, for other angles theta, multiply the final answer, or the initial integral, by theta over 2 pi in radians, or theta over 360 in degrees. Because they did ask a question in the exam once about if you rotate by an angle of 270 degrees or something, and so that just adds another layer of difficulty, but I think this is reasonably straightforward to figure out just by thinking about what you have to change in this setup, because you don't want the whole, so going right back to the beginning, we don't want the whole volume of this cylinder. If we just want 3/4 of it, we're just going to multiply the whole thing by 3/4. So that's how you deal with angles other than 2 pi radians. Just to add to this example, the final answer is not 128 pi over 3. We forgot to add the 4 pi, the volume of the cylinder. So therefore, the total volume is 128 thirds pi plus 4 pi, which is 140 over 3 pi. So this is actually the final answer.